Hello everyone. Here we are going to see you block 4 game theory, and in that block unit 14 have been going to see. It is game with saddle point, game without saddle point. Structure of this unit is objectives, introduction, types of strategies, definition, procedure to determine with and without saddle point, solved examples, sum up keywords and terminal questions. First one is objective of this unit. The strategy for a player is the list of all possible actions, that is, moves or course of action, that he will take for every payoff or outcome that might arise. It is assumed that all course of possible actions are known in advance to the player. Okay, then introduction. A saddle point in a two-person constant sum game is the outcome that the rational player would choose. A saddle point always exists in games of perfect information, but may or may not exist in game of imperfect information. By choosing a strategy associated with this outcome, each player obtains an amount or at least equal to his payoff at that outcome, no matter what the out player does. This payoff is called value of the game, and as in perfect information games, it is determined by the player's choice of strategies associated with saddle point, making such games strictly determined. A rectangular game without a saddle point cannot be solved using pure strategies. It is solved only by using mixed strategies with minimax and max-min criterion of optimality. So, in this case, the best strategy are the mixed strategies. In this strategy, the probability with which each action should be selected is calculated. The following theorem is followed to find the solution of a two-person 2 by 2 matrix without a saddle point. Then we are going to see the types of strategies. Two important types of strategies are there. First thing is a pure strategy, and the second thing is mixed strategy. So, first, pure strategy. Pure strategy means a particular course of action that are selected by the player. The definition for pure strategy is particular course of action that are selected by the players is called pure strategy. That is a course of action. Each player knows in advance of all strategies, out of which he always selects only one particular strategy of the other player's strategy, and the objective of player is to maximize gain or minimize lose. This is what the main important strategy for the players, to maximize gain or minimize loss. Next thing is a mixed strategy, a course of action that are to be selected on a particular occasion with one fixed probabilities are called mixed strategies. Here we are going to use a probability. That is, there is a probabilistic situation and objective of the players is to maximize expected gain or minimize expected losses by making choice among pure strategy with fixed probabilities. And in this mixed strategy, if there are n number of pure strategies of the player, there exists a set S is equal to P1, P2 and so on Pn, where Pj is the probability with which the pure strategy J would be selected and whose sum is unity. Yes, as we all know that a total probability is 1, right? So that is what we are going to use. That is a P1 plus P2 plus and so on up to Pn is equal to 1. And Pj is strictly greater than or equal to 0 for all j equal to 1 to n. Next, some definition. If max min value is equal to min max value, then the game is said to be have a saddle point. Otherwise, in the sense max min value is not equal to min max value, then the game is said to be game without saddle point. Game without saddle point. Some remarks are there. That is, the first thing is the corresponding strategies at saddle point are called optimum strategy. And the second thing is the amount of payoff at a saddle point is known as the value of the game. And the game may have more than one saddle point. Game may have more than one saddle point. There are a game without saddle point. Its name derives from its beginning, the minimum of a row, that is also the maximum of a column in a payoff matrix, to be illustrated shortly, with corresponds to the shape of a saddle. Then next thing is a procedure to determine the saddle point. Procedure to determine the saddle point. Here, first you are going to find the minimum value in each row and write it at the end of the each row. Next step is to find the maximum value in each column and enter it in the bottom of each column. Okay, here row wise we have to pick the minimum value, and for column wise we have to pick the maximum value. And the third step is to select the largest element in row minima and select the lowest element in column minima. Column minima. Yes, we have to select smallest value in the row minima and we have to pick the lowest element in the column maxima. Next step is to maximum of row minima, that is maximin, is equal to minimum of column maxima, that is min max. If it is both are equal means it has saddle point, that is the game has a saddle point. Otherwise the payoff at the saddle point is called the value of the game. Otherwise in the sense, if maximum of row minimum, that is maximin, is not equal to minimum of column maxima, that is min max, means game without saddle point. Game without saddle point. In that case, we have to use that probability to find the value of the game. To find the value of the game. Next one, games with saddle point. Games with saddle point. It is also known as pure strategy. Pure strategy. Suppose if there is no pure strategy solution for a game, then there is no saddle point exist. If these situations to solve the game, both the player must determine the optimal mixtures of strategies to find saddle point. The optimum strategy mixture of each player may be determined by assigning each strategy its probability of being chosen. The optimum strategy determined here is called mixed strategy. Yes. Then fair game. Fair game. If the value of the game is 0, value of the game is 0, that is there is no loss or gain for any player. The game is called fair game. The simplest type of game is one where the best strategy for both players or pure strategies. This is the case if and only if the payoff matrix contains a saddle point. Next thing is strictly determinable. A game is said to be strictly determinable if the max min and min max values of the game are equal and both equals the value of the game. Both equals the value of the game. Then procedure to solve 2 by 2 games without saddle point. 2 by 2 games without saddle point. If payoff matrix for player A is given by player A and B is given by A11, A12, A21, A22. Then the following formula are used to find the value of the game and optimal strategy. Here P1 is equal to A22 minus A21 divided by A11 plus A22 minus of A12 plus A21. And P2 is equal to 1 minus P1, that is P1 plus P2 is equal to 1. The total probability is 1, right? That is what here P2 is equal to 1 minus P1. And Q2 is having the formula A22 minus A12 divided by A11 plus A22 minus of A12 plus A21. And Q2 is equal to 1 minus Q1. And value of the game, it is represented by V. So V is equal to A11, A22 minus A21, A12 divided by A11 plus A22 minus A12 plus A21. Hence, the optimal mixed strategy for player A and B is given by SA is equal to A1, A2 and P1, P2. And SB is equal to B1, B2, Q1, Q2. Here P1 is equal to probability of player A, choose strategy A1. P2 is equal to probability of player A, choose strategy A2. Whereas Q1 is equal to probability of player A, choose strategy B1, and Q2 is equal to probability of player A, choose strategy B2. Here, one example has been given for you, game with saddle point. So what's given in the problem? Find the solution of a game theory problem using saddle point. Yes. So first column denotes a player A, second row wise denotes a player B. So first you are going to test whether this game has a saddle point or not. For that, we have to apply max min principle or min max principle to analyze whether this game has an saddle point or not. Okay, so for that, row wise, first step is we have row wise we have to pick the minimum value. In the first row the minimum value is 12. The minimum value is 12, so we have to write it here. Okay, and in the second row the minimum value is 8, and in the third row the minimum value is 2, so we have to write the 2 here. Okay, and in the fourth row the minimum value is minus 5, so minus 5. And column wise we have to write the maximum value. In the first column the maximum value is 40, so write it here, 40. And in the second column the maximum value is 15, and in the third column the maximum value is 12, and in the fourth column the maximum value is 35. Okay, then we have to find minimax from the maximum of columns. So column minimax in the column maximum values we have to write the minimum value out of these four values. We have to pick the minimum value. It is 12. Then select the maximum from minimum value of rows. Out of these four minimum values of rows we have to write the maximum value. It is 12. So row maximin equal to 12. Hence, column minimax equal to row maximin. Why? Because means both are equal. 12. Hence, this game has a saddle point and the value of the game is also 12. The value of the game is also 12. How the value of the game is 12? The intersection point of min max and maximin. The intersection point of min max and max min value is called the value of the game. Okay, so this game has a saddle point and the value of the game is also 12, and the value of the game is also. So this game has a saddle point and the value of the game is 12. And the value of the game is 12. The optimal strategies for both players are the player will always adopt strategies 1 and the player will always adopt strategies 3. Moving on to the next example. For the example for the game with payoff matrix, they have given the payoff matrix. By using this matrix we have to determine the best strategies for player A and B, and also the value of the game. Is this game is fair game or strictly determinable game? Okay, so let's see the solution of this game. First, we are going to find whether this game gives a saddle point with saddle point or without saddle point. For that, we have to find first row minimum. Row wise minimum value is -2. Then the second row has the minimum value is -6. Column wise, we have to pick the maximum value. So first column has the maximum value 6, and second column has the maximum value 4, and the third column has the maximum value -2. Select the minimum from the column maximum values. So out of these three maximum values we have to pick the minimum. It is -2, and min max is equal to 1. Select the maximum from the row minimum values, that is max min is equal to 1. Player A will choose strategy 1 which yields the maximum payoff of minus 2. Player B will choose strategy 3. The value of game is minus 2. The value of game is minus 2, which indicates the player A will gain minus 2 unit and player B will sacrifice minus 2 unit. Minus 2 unit. So the value of the game is minus 2, which indicates the player A will gain minus 2 unit and player B will sacrifice minus 2 unit. Since the maximin value equal to min max value equal to minus 2. Okay, therefore the game has saddle point and the game is not fair game. Since value of the game is non-zero. Yes, fair game means the value of the game is 0. Here we are having some value, right? So value of the game is non-zero. Therefore, it is not a fair game. Also, maximin equal to minimax equal to value of the game. Therefore, the game is strictly determinable. It is a pure strategy game and the saddle point is in A1 and for B third place 3. The optimal strategies for both players given by pure strategy. Player A must select strategy 2 and player B must select strategy 3. Then the next example, find the range of values of P and Q which will render the entry 2, 2 a saddle point for the game. So they have given a payoff matrix. First, we are going to check whether this game has a saddle point or not. For that, first we are going to find row minimum values and column maximum values. Here, after that, max min is 7, min max is 6. That is the value of the game may be in between 6 and 7. That is max min is not equal to min max. Therefore, there is no unique saddle point. Game with no saddle point should solved using mixed strategies. If the saddle point exists at 2 2, only if Q greater than 7 and P greater than or equal to 7. Next example number 4. Two player A and B match coins. If the coins match, then A wins 2 units of the game. If coins does not match, then B win 2 units of the values. Determine the optimum strategies for players and the value of the game. First, let us construct payoff matrix for player A. Yes, if the coins match, then A wins 2 units. If the coins match means player A and B. I mean, if it toss coin means if toss 2 coins simultaneously means both the coins gives head means we have to give 2 units. Okay, then the coin does not match means one coin gives head and other coin gives tails means we will give -2. We will give -2 or B wins 2 units for the value. Okay, that is what. If head means we will give 2, head tail means we will give minus 2 units, and here also head tail means minus 2 units, tail and tail means 2 units. Okay, after that, find row minimum value and column maximum value. Since max min and min max min value is minus 2 and min max value is 2, that is the value of the game lies between minus 2 and 2, that is max min is not equal to min max, therefore there is no unique saddle point. Game with no saddle point should be solved using mixed strategy. As we all know that it is a 2 by 2 game without saddle point, we use the following formula, that is P1 is equal to A22 minus A21 by A11 plus A22 minus of A12 plus A21. So A22 means 2, second row second place, and minus of A21 means second row first place, second row first place, it is minus 2 divided by A11 means first row first place, it is 2 plus A22 means second row second place, it is also again 2, and minus of A12 means first row second place minus 2, and A21 means second row first place, it is also minus 2. So minus of minus plus 4 divided by 4 plus 4 plus 4, it is 8, which is equivalent to half, 1 by 2. So P2 is equivalent to 1 minus P1, 1 minus half is half. Similarly, Q1 is going to find, so Q1 is equal to, it is calculated by using this formula, and it will be 4 by 8, it is half. Again, Q2 is equivalent to 1 minus Q1, that is 1 minus half is half. Therefore, it is a fair game. Hence, the optimum mixed strategy for player A and B is given by SA equal to head tail, that is half and half, SB equivalent to half and half. Okay, P1 P2 values. Then sum up is given. In this unit, students have learned to solve the game with saddle point and game without saddle point. Some keywords have been given for you. Zero sum game. The algebraic sum of gains and losses of all players is 0 is called zero sum game, and players who is interacting in the game are called players. Pure strategies. It is a decision rule always to select a particular course of action. A particular course of action. And some terminal questions have been given for you. Let's make use of it. Thank you. We'll see you in the next unit.